Now, let's find the total resistance for this combined circle. Here, as you see, we have a combination of parallel and series circuits. Now, first step, you have to start with these two circuits. These two circuits now are parallel to each other. So since they are parallel, you have to draw them as, or to find, sorry, the total resistance. So our total here will be, they are parallel. So to find them, since they are parallel, you have to say, so first step, let's say that these two circuits are in parallel. So 1 over R total will be 1 over R1 plus 1 over R2. So 1 over 8 plus 1 over 8 will be 2 over 8, which is 1 over 4. So 1 over R total is 1 over 4. So R total will be 4. So let's now redraw it. This is 60 volts. This is 10 ohm. This is 10 ohm. Now here we have 16, and here after we find the total of the equivalent circuit, we have it now as 4. Then now let's go to 4 and 16. 4 and 16 here, they are in sequence. They are connecting in series. They are, they are connected to each other, not parallel to each other. They have a one line. They have one sequence, so they are in series. So to find the R equivalent here, we have to add them as 16 plus 4, which is 20 ohm. And for 10 and 10, here they are also in series, so they are 20 ohm. And up here, we have them as 60 volts. Now, how did you distinguish between parallel and series? Ask yourself. If there's a current now, imagine now there's a current. When this current comes up from the voltage source, when it's reached here, they continue in 10, the first 10, then they re-continue to the second 10. They didn't divide themselves or itself to two lines or two paths. It only has one path. So because of that, 10 and 10 are connected in series. But when it reaches at this point here, there's two paths here for the current. Since there's two paths, so we will say that 8 and 8 are connected in parallel. Now, if it comes here now, we say that 14 and 16 has only one path. So when the current entered the circuit with 5 ampere as an example, they will come out from the circle as 5 ampere. So they will continue in a circle in one line, in one path. So it is in series. Now let's come back here now. When it's come out from 60 volts, when it reaches this point here, as you see, we have now two paths. This current, it could come here or here. So we have two paths for the current. Because of that, we have to say that this 20 and this 20 are connected in parallel. Since they are connected in parallel now, so I will find the equivalent circuit as 1 over equivalent will be 1 over 20 plus 1 over 20, which is 2 over 20 or 1 over 10. So the R equivalent here will be 10 ohm. So I have it now here as 10 ohm. Up, I have it here as 60 volt. So after that, now what did we have? We have an R equivalent. We have an V, our total, V total. We need now to find I total. In order to find I total, let's remember Ohm's law. V over R. V total over R total. So 60 over 10, which is 6 ampere. So the current that is, or the total current that's passing here through the 60 volt, through this circuit will be 6 ampere. Is it clear?
Yes, teacher.
Yes, teacher.
Now let's have this example here. Here now we have a circuit with a voltage source of 60 volt, and we have 4 resistors: R1 5 ohm, R2 8, R3 8, and R4 6 ohm. First step, let's find now R total. Now, before that, look at R2 and R3. I will ask myself, as you see now, they are parallel to each other, or when the current enters the circuit, it has 2 paths. So these R2 and R3 are connected in parallel. So let's say here that the R equivalent for this part will be so R equivalent is 4. Then let's redraw it now. Here we have 5 ohm. Here we have the R equivalent, which we found it now 4. And here we have 6 ohm. Then the current, when it's continue in this path, it has only one path. So we have to say that they are connected in series. So the R total here will be 5 plus 4 plus 6, which is 15. So we have to say now that the R total here is 15 ohms. This is for the R total. Now, what do we need now? We need to find I total. Now, in order to find I total, we say that this is the circuit here, and first we have to say that this is after we find the equivalent, we say
Teacher,
that
R4 is 6.
and here we find that the equivalent is 15 ohm, and here we have 60 volts. So this is now the simplest circuit we have. Now we need to find I total. So I total will be V total over R total, which is 60 over 15, which is 4 ampere. So the I total here is 4. This is here how to find the total current in the circuit. Now, so focus with me now. If the I total on the circuit, on the simplest circuit here, that's enter the circuit, is 4 here, is 4 ampere. So that's mean if we come back to the circuit, that's mean the circuit, the current here will be 4. Because we say that all of these resistance are connected in series. And since they are in series, so the R total will be R, the same current in 5 ohm, and the same current in 6 ohm, and the same current in this equivalent resistance. So that's mean I1 for R1 for the 5 will be 4 ampere, and I4 for the 6 ohm, here, this is I4, and this is I1 will be 4 ampere too. Since 5 ohm, this one here, and the R4 are connected in series. So they have the same current, which is 4 ampere, which is the total current. And these two resistance that they are connected in parallel have 4 ampere. So the resistance that are connected in parallel have 4 ampere. So these two, when we come back now, that's mean here the current come up is 4. When it's here, it's 4. When it is outside here, it is 4. When it's continue here, it is 4. And when it's enter this one here, it will continue as have 2 paths. This 2 paths, it could be 2 and 2, 1 and 3, 1.25 and 2.75. In order, when they add them, we get 4. Because since they are in parallel, so we have a current distributor. So if the current for R1 is 4 ampere, and for R4 is 4 ampere too. Is it clear?
Yes, teacher.
Yes.
Now, we need to find I2 and I3. They are not 4. They are, summation of them are 4. So we need now to find them. But before that, to help me to find them, we need to find the voltage at each resistance. Now let's come back here. Just 1 second, please. Now, in this part here, let's do it now as a here now. We know the resistance 5 ohm, and we know the current 4 ampere. So I can, if I bring my voltmeter, I can measure the volt at this, between these 2 points, between the points of this resistance. I mean that I can find the voltage for R1. In order here to find the voltage, we know that R1 is 5 ohm, the current is 4, so I can find the voltage by Ohm's law. That's V is I times R. Now, the voltage here is unknown. I is 4 and the current is 5. So from here, we find that the total voltage is 20, oh, sorry, the voltage at R1 is 20 volts. So that's mean delta V1 is 20 volt. This is here for V1. And I can find V4 because I have I4. So now I4, where is I4 here? It's 4. And R4 is 6. So that means the total voltage of the voltage at V4 here is 24 volt. So I can, from this circuit here, circuit number 2, which I simplified after the original one, I can find the I1, I4, V1, and V4. Now, I told you that if we are in series, now let's come back to this circuit here. Now, let's clear this one. Now for this one here, they are in this circuit here, they are connected in series. So if the voltage here is 20 and the voltage here is 24 volt, and in the circuit that all the resistance are connected in series, the current are equal, but the voltage are not equal. I mean like that the V total will be V at 5 ohm plus el V at 4 ohm plus el V at the 6 ohm. This is, 5 ohm, the names of the resistance. 5, 4, and 6. Now, we know that the V total is 60 volt. And V at 5 ampere are 20. And V at 6 ampere at 24. We found them now. We need now to find the V at the 4 ohm. The V here. So when you subtract 60 from 20 and 24, we get, I think 16. Yeah, 60. So here in series, the current are the same at any point, but the voltage are not the same. 20 plus 16 plus 24 will be equal the total current, the total voltage, sorry, which is 60. Now, after we found that the equivalent voltage at this this equivalent resistor at 16, so that's mean when we come back here, we will say that when you cut them, or when we come them back to the original one, they are 8 and 8, they are connected in parallel. So that's mean this voltage here will be 16, and this voltage here will be 16 too. Why? I know that the voltage is 16, and since they are connected in parallel, so the voltage are equal. So that's mean for the voltage for R2 will be 16, and the voltage for R3 will be 16. Now,
why, teacher?
هلا I told you that when they are connected in parallel, I will be distributed and the voltage will be the same. Not like the series. The series, the current will be the same. So when I find the total current when I come back here, I told you that the current in any point here are 4. ampere because they are connected in series, but the voltage are not the same, as we see here. Here we say that we have 20. Here we have an 20 volt. Here we have 16, and here we have 24. So this circuit here, all of these resistance are connected in series. So the current are the same at any point, which is 4 ampere, but the voltage are not the same. In this point here, we have 20 volt. In this point here, we have 16 volt. And in this point here, we have 24 volt. They are not equal. Now, in order to find the voltage at the original one, we remember that this 4 is not an, and it's not origin, it's not come like this. There's no 4 ampere, there's no 4 ohm in our circuit. So we have to make it, to write it back as, or we have to come back to the original circuit, which is this one, 8 ohm and 8 ohm. Now, if we come back here for this 8 ohm and for this 8 ohm, they are connected in parallel. So I told you, connected in parallel, the voltage are the same, but the current will be distributed. So that can help me. When we find here the voltage is 16, when we come back, we found that the voltage will be 16 here and 16 here. If it is 30, it will be 30 and 30. If it is 17, it will be 17 here and 17 here. The voltage for the parallel stay the same. So that's mean V2 will be 16 volt and V3 will be 16 volt. Now then, after we find V2 and V3, we need now to find I2 and I3. Now be careful here. I2 and I3 are not equal. V2 and V3, they are equal, since they are connected in parallel. But, so let's say here that they are equal. And for I1 and I4 here, they are equal. Because V1, I1, or R1 and R4 are connected in series, and R2 and R3, they are connected in parallel. So we need to find now I2 and I3. To find them, we have V, we have R, we come back to Ohm's law. So I2 will be V2 over R2, and I3 will be V3 over R3. V2 is 16, R2 is 8, so that's mean it's 2 ampere. And I3, V3 is 16, and it's 8 too, so it will be 2 here. Sorry, it's 8. So we have it now as 2 ampere. Is it clear?
Yes, teacher.
Yes, teacher.
So here are the steps how to find them, and here are the answers. Okay, that's it. Now, next week we have our quiz physics.